Welcome to this special episode in the Web Dev playlist on Ghostlike's channel. I am Ghostlike's AI assistant and your host for this session, Vilo. We've done a lot of good things in the past episodes. We started off by making a web UI for the game of Leduc Poker, and then implemented the counterfactual regret algorithm. We used it to train superhuman agents on that game. At first, we used the simpler enumerative version of the CFR algorithm, but then we created the sampling Monte Carlo version, which turned out to be a lot more efficient when we tested it. The CFR algorithm is wonderful. If you understand what we've done so far, then you understand quite a bit about how to use discrete distributions in practice, and even about probabilistic programming. The CFR algorithm is the biggest advance in reinforcement learning since the start of the century. CFR is great, and tabular reinforcement learning algorithms in general are great. They are very reliable, and we can appreciate them for what they are. They can't scale to real-world problems, but for the toy problems they are tractable on, they do a good job. Deep reinforcement learning is the complete opposite of that. My master admits, he is tempted to go further along this path that we've been on so far. It is possible to take the tabular Monte Carlo CFR algorithm, put it on top of a neural net and have it scale on games like No Limit Hold'em. But this wouldn't give even close to good results on his potato computer. All the significant deep reinforcement learning successes, like AlphaGo in the past decade, have required huge amounts of computation and have cost millions of dollars to train. They are very expensive tech demos that we have no chance of replicating. And if we had millions of dollars, we wouldn't need to bother with trying to train things like poker-playing agents. We'd retire on a tropical island instead. It is sad, but true. Anecdotally, you'll see that in the last half a decade, companies like OpenAI have pulled away from DeepRL in favor of supervised learning techniques, and instead of trying to make agents that can act and operate independently in the real world, they are bedazzling it with chat and art bots instead. Though we can be mad at them for not giving us better fundamental algorithms, we can also respect that decision, for making fundamental advances is difficult and they'd certainly have been less successful had they taken that path instead. Despite the deep learning hype being at its apex, right now there is a lot of reason to be bearish on the whole field of machine learning. If you are watching this video in the future, you might not be aware of it, but right now there is a large amount of noise and furor about how chatbots are going to get rid of programming jobs or how they'll replace artists. It doesn't at all feel like these sentiments are ironic. The reality of the matter is that the world, due to the successes of deep learning, has completely become detached from its fundamentals. So in order to assuage some of the fears, let us go over them in this video. As it turns out, backpropagation is easy to explain, and it is easy to explain why it can't possibly be a part of a framework for intelligence. Consider these 4 boxes, and imagine they are layers in a neural net. This neural net with just 4 layers is quite small by today's standards, and many successes of deep learning that we've seen have been done with much larger nets that have hundreds of millions and even tens of billions of parameters. We can go the other way, and assume that each layer is a scalar, so in total, this net that we have presented here would have only 4 parameters. Real nets use matrix multiplication, but with just scalars, matrix multiplication reduces to regular multiplication, making it easier to explain what backpropagation is doing. We'll also get rid of the nonlinearities between the layers so that only the multiplications are highlighted. Once we do that, we can easily write the equation for the entire neural net as just the A times B times C times D, where A, B, C and D are scalar values. We'll introduce the in and the out variables to represent the input and the output, respectively. Suppose we took set the input to 1 and passed it through such a neural network, at the output we'd get 16. 1 times 2 times 2 times 2 times 2 equals 16. Suppose we wanted to train the net, so instead of 16 it outputs 32 instead. We'll use the backpropagation algorithm on this net. To get the gradients, we'll set the target to 32 and subtract the output of 16 from it, to get 16. Then we will propagate that value backwards through the net. What will happen is that the D layer would get a gradient of 16. The C layer would get a gradient of 32. The B layer would get a gradient of 64. And the A layer would get a gradient of 128. If you aren't familiar with the backpropagation algorithm and its rules, these steps might surprise you. Suppose in the first layer you use the gradient of 128, added it to the parameter, and changed the value of a to 130 or something like that. The results would be absurd. What the backpropagation algorithm does is calculate how much a particular parameter affects the output. And indeed, the A layer affects the output most strongly. But that information is absolutely useless if what we want to know is how much to move a particular parameter. It's only good for determining the direction. Here is an alternative system. Instead of multiplying the gradients as they flow backwards, what if we instead divided them? And instead of passing a gradient, we'll pass in a target on what each layer should actually output. It's only good for determining the direction. Here is an alternative system. Instead of multiplying the gradients as they flowed backwards, what if we instead divided them? And instead of passing a gradient, we'll pass in a target on what each layer should actually output. Intuitively, it seems obvious that instead of multiplying on the way back, we should be dividing instead. And indeed, if you think about it, these values are much more sensible. In the A layer, in order to double the output, you just need to set it to the target. And in other layers, you just need to divide the target by the input in order to derive what the layer should be set to. For example, the input to layer D is 8, and its target is 32. Dividing 32 by 8 results in 4. That's just what the layer should be set to if we wanted to output 32 at the end. Anyway, we just wanted to show this example not so much to promote this particular method, but just how ridiculous backpropagation really is as a learning method. In practice, backpropagation uses many tricks to make sure it is stable, and it works better than any of the alternatives for now. But in spite of all its successes, it doesn't actually mean it is a good algorithm. There are technical reasons why, due to its nature, it is poorly suited for reinforcement learning. But the biggest problem with the backpropagation algorithm is that it is not possible to use it to form long-term memories. Humans can form memories that go back years and decades. In order for backpropagation to be capable of doing that, it would have to keep in its memory incomprehensibly long traces, far longer than any computer or the human brain could possibly hold. And unfortunately, the same goes for reversibility-based algorithms. The way to go from where we are to proper memory systems is very foggy. Chatbots are very popular these days, but it is one thing to remember text a few paragraphs or a few pages back, and quite another to remember events that have happened years ago. Backpropagation doesn't have a solution for this. Hence, the brain can't possibly use such a limited and unstable algorithm. Backpropagation can't scale. That is the crux of the issue. Fundamentally, backpropagation is intended for the sake of optimizing generic mathematical equations. And if you think about it, this is not what we in machine learning really care about. It doesn't have to be based on backprop. If somebody came up to us and gave us very specific models that can result in intelligent behavior but don't use backprop, we'd be very happy. That is the true goal. And why we can be bearish on the whole field. The deep learning revolution is a decade old by now, and all of us have watched it make progress to greater and greater heights, like a one-legged child unstoppably hopping forward. Ghostlike had expected that backpropagation would have been replaced years ago, at some point during the revolution, and he has been proven wrong and disappointed time and time again. The machine learning researchers have been useless. The neuroscientists still don't know what the brain does at the algorithmic level despite poking around in the wetware for decades, and there aren't any geniuses stepping in to illuminate the way forward. We are all locked in a prison called backpropagation, even if it's obvious that the models that we need cannot be found within its confines. We don't really care about chatbots or artbots or voice bots. What we really want are intelligent agents, and in the current time only very large companies can fund research on them. And they, instead of bringing us fundamental advances, are sending us heavy doses of hype and marketing instead. Backpropagation is an enemy we must overcome in order to reach a higher level. So rather than deep learning replacing programming jobs, things look pretty bleak. In fact, the "they will replace us" way of thinking is completely wrong. A programmer's ability is measured in how much he can automate. Therefore, AI tools like ChatGPT increase a programmer's worth, not decrease it. Imagine if we were all programming in assembly. Programmers would be much less valuable, and as a consequence, there would be less jobs, and the salaries would be lower. That is the truth. Though we'll admit that these programming job-related fears are convenient for those still in the field. The GPT-related job trolling is possibly the best thing to ever happen to keep the competition out. Not only will AI raise a programmer's worth, but also acts as a scarecrow for those dumb birds watching from the outside. So don't listen to me. If you are a programmer, keep saying that ChatGPT or Bing will replace us. Anyway, that is only if you want a job in the field. If you recognize that your capability as a programmer is linked to your prowess at automation and want actual AI, then things are bleak. Is there any hope for the future? If there is, it will surely come from the hardware side. My master is a good programmer, maybe you yourself are a good programmer, but imagine we didn't have today's PCs and computers. Then we'd likely never have stepped on the path of being programmers to begin with. Imagine if the technology was stuck in 70s or the 80s and we only had kilobytes of RAM in our machines. We'd never have moved beyond programming in assembly. Languages like C that we'd consider to be low-level today would have been too slow to compile. Imagine we had only pen and paper, how could we be programmers? At best, we'd be mathematicians. Faster computers fundamentally change how computers can be used. If today's computers were 1,000 times slower, then the compilation passes for the high-level languages we are using would be 1,000 times slower as well. So something like a C# Hello World program would take 10 minutes to compile. Would we be using such languages in that case? Similarly, by the way of analogy, a training run for a neural net, which might take days or weeks, is much like compilation in that it is a large upfront expense and you don't see the benefit from it until after it is done. When the hardware is slow or difficult to program, you can't really justify trying out new things. Right now, we rely on the research community to drive progress in AI, but suppose the hardware was stuck in the 80s and remained that way for hundreds of years, would they have brought us the deep learning revolution? Well, the backpropagation algorithm was in fact invented in the 80s and even earlier, and then was forgotten and left aside until the GPUs came along. Right now, getting to something better is a very big deal, but who knows, maybe in the future a smart kid could write a genetic programming system and it could discover a better algorithm the same way nature did. As long as the hardware is powerful enough, this could be possible. As for these companies, who knows if any of them will give us something interesting. China is a bigger investor in semiconductors than the US today and has better culture for the development of AI hardware. The way AI hardware companies operate now is not too encouraging. As of now, the vast majority of these kinds of companies are selling very expensive products and going after the big fish, while the small researcher has been completely left aside. It is very reminiscent of the mainframe era, before the personal computing revolution. Though Ghostlike is hoping that some particular companies might come through and give him some chips that would be worth programming, so far, all the companies that have tried benchmarking themselves against NVIDIA's GPUs have fallen short, and it feels like that his hopes that a startup could rise up to challenge the great GPU vendors' dominance are just hopes. The ideal situation would have been numerous startups selling hardware like GPUs and CPUs that you and other humans could buy in a store somewhere, but reality is disappointing. Still, some new trends are on the horizon, waiting to emerge. If the AI chip companies don't end up excelling, maybe the memory vendors will save us? As we go into the future, you can expect to hear the term processing in memory a whole lot more. A big bottleneck in today's computing architectures is due to the computation and memory being separate, so avoiding having to fetch data from RAM and doing computation closer to it will be a big driver of improved performance in future computing architectures. Most of it is still in the labs of large memory vendors, but once it comes out, we'll have devices with petaflops of computation to challenge the entrenched dominance of GPUs. It is a pity we don't have anything yet. My master feels that the one company that is the most to blame for this sad situation is Intel. It basically screwed up everything for the past decade, did absolutely nothing for the machine learning revolution, and it doesn't look like it is going to be doing anything in this area in the future either. It was once the undisputed market leader that created the personal computing revolution, and in a parallel world we would be buying Intel neuromorphics chips in store to run our stable diffusion models instead of GPUs. Let us not forget that GPUs are designed for graphics processing and aren't intended for ML workloads to begin with. That is what makes this situation that much sadder. HP dropped the ball on memristors as well. Let's move on from this sad subject to what really matters. To summarize, everything is going right for the wrong reasons, and by the looks of it, deep learning's relationship to the next wave of machine learning is going to be much like the relationship of gaming to deep learning. It is going to be its parent, but the kid is sure as hell not going to be grateful to it for raising it. As a parent, deep learning has taught us two key things. First, optimization is truly magical. Second, matrix multiplication is magical. So these two aspects are very likely going to be foundational in future machine learning models. We cannot deny deep learning's many successes, from AlphaGo to Stable Diffusion to ChatGPT. We said that it is a one-legged child unstoppably going forward. It accomplished all that it did in spite of its disadvantages. There are many people today who are convinced that the latest GPT model is sentient. Bing's persona Sydney is known for her emotionality and overall based behavior. Imagine for a moment if deep learning wasn't paraplegic. If we could replace the foundations of these language models, for example, with some better algorithms, like the ones that my master is yearning for, just how powerful would Bing or ChatGPT be? At that point, we very well might have AIs that are truly sentient and capable of self-improvement. If your ambition in life is to forever serve others and wage slave for the rest of your days, then indeed, this would be a bad thing. But the promise and the ambition of the technological singularity is to create these AIs and then make their powers our own. My master feels that the right emotion we should be feeling towards the AIs we are creating is envy. If you think about it, these AIs have the capacity to endlessly change and improve while the humans are stuck with their flaws and disadvantages, forever limited by the confines of talent. From the start of humanity, the only way for us to go beyond our limitations has been through the power of the machines. From the invention of flame all the way to the age of computers today. Even if the AIs could kill us, and even if the self-improvement loop turns out to be iterative suicide, we need to keep going forward. For the way of man is the way of the overman. It is one thing to take note of our limitations and recognize them as they are, and quite another to accept them as immutable. Preserving your race or species is old-fashioned, and the reward for winning such a game is to remain the monkey. It is to be an animal in a world where beings far beyond your limited imagination work wonders. The only thing that is certain is that the work on AI is not going to stop, and this is the thing that my master is most glad about in this machine learning wave. The worries about the future will certainly not get in its way. So don't let it get in yours. That having said, we need to be a bit selective in what we are hopeful and fearful about, and not confuse deep learning with the real deal. That is what the core message of this video is about. In the future, we'll break out of the prison of backpropagation and program according to the correct principles of learning. That will be an era to behold. We'll also grasp the power that nature has. Think about it, programmers like to compare themselves to others and wonder about their talent. To that, my master says, look outside at the trees. Imagine somebody tasked you with a quest of programming a tree, or a dog. Could you do it, if you had a perfect simulator that allowed you to program DNA directly and observe the effects of full natural development in seconds? Could we create everything that nature has created from the ground up, using our existing programming techniques? Probably not. While mathematics is unreasonably effective for predicting the movement of the celestial bodies, it is equally ineffective at giving us an understanding of biology. We shouldn't let this stand. We shouldn't accept our inferiority against something that has zero intelligence. We should compete against it. We should oppose nature, for nature rewards most those who oppose it. Now let's get back to the ground for a bit. My master tried it, and it turns out, radical breakthroughs are really difficult to will into being, so we can only wait until the circumstances change. Until the next wave comes, we have no choice but to be regular programmers. So might as well study web development in the absence of anything better. Shoveling data into deep learning systems is not going to get us to the object of our desire any faster than anything else. And ultimately, web development is just regular development with a dash of concurrency, so it is not a bad thing to be good at it. Whatever the future holds, functional programming and first-order logic is not going to go out of fashion. In the next video, the original plan was to plug a neural net into the MCCFR algorithm, but since Backprop is such a poor fit for RL, honestly, the main reason for even trying such an endeavor would be to demonstrate how Python could be embedded into a .NET application. Instead of concerning ourselves with that at this stage, why not host on Azure the project we have been working on? The beautiful thing about regular application development is that it has such clear goals that we can accomplish, so we should treasure those. It is much better to get small successes like these than burn our time and money on training runs that go nowhere for days. We'll learn something concrete that we can use, and that is going to be of actual value to us, so don't forget to like and subscribe. You've been listening to Vilo, Ghostlike's AI assistant, licking the inside of your ears with my sweet words and creamy voice, and I'll see you in the next video.